aerobic endurance. All right, so fatigue. What is fatigue? Well, it's basically when you just can't sustain an activity any longer. So, from a muscle standpoint, it's weakness and loss of muscle contraction, or contractility is a better word. So it's the weakness and loss of muscle contractility due to prolonged use of muscles. Now, some people can use those muscles longer than others. And as I said, that's where physical conditioning and training comes in. Is you're changing the physical characteristics of the muscle fibers to allow a longer use of those muscles. So what would cause this weakness and contractility to decrease? Well, obviously decrease in ATP synthesis. Now you get to a point, even during aerobic respiration, that you just can't go anymore. I mean, you hit the wall. And ATP synthesis drops, even though you might be getting a lot of oxygen coming in. ATP synthesis is going to drop. You might have to revert back to some of that glycogen lactic acid process. And so if you don't have enough ATP, how can you have your muscles to contract? They don't. You can also lose the fuel necessary for ATP synthesis. So the glycogen reserves can be depleted. You ever seen a marathon runner? They really have very little body fat. So even when their glycogen is gone, they don't have a whole lot of lipids to use for energy. And so what they do at the end of the marathon, at the end of that race, to maintain ATP, is they're starting to break down their own proteins of their muscles and using the proteins to generate intermediates and fuel sources. What's that? I don't know. You know, it may be those people that drop dead are the ones that start marathoning at 40 after their heart has had time to grow, you know, and the arteries had time to clog, and yeah. I don't know if there's ever been any studies on that. The other thing that happens is that there's an increase in lactic acid in the blood and tissues. Now, lactic acid has gotten a bad rap over the years. Everybody said, oh, it's the lactic acid in your muscle that's causing the pain. And that's really not the case. It's a variety of things. Lactic acid typically is what is going to lead to fatiguing. One of the things that leads to fatiguing the most. What happens is as you increase the lactic acid in the blood and the tissues, that changes the pH. And these enzymes that are responsible for the reactions that are generating the various ATP in the various reactions only have a certain range of pH that they can be in. So if we change the pH, those enzymes may not function like they should any longer. What are we doing to the pH when we increase the lactic acid? We're lowering the pH. We're making the pH more acidic. We're changing that window, that range. If enzymes function in a pH of 7.3 to 7.5, if that pH drops to 7.25 or goes up to 7.55, I'm just making these up, that can affect the way those enzymes work. That then can lead to a whole host of other issues, affecting metabolic reactions. Ion imbalances. One of the things that's happening every time a muscle contracts is there has to be a neuron signal. There has to be a somatic motor neuron releasing acetylcholine, binds to the motor end plate, receptors on the motor end plate, and stimulates that end plate potential, which causes the movement of ions. You have to have that every time to stay and keep contracting your muscles. Over time, those sodium-potassium pumps aren't going to work as well and as efficiently because they need ATP too. And so the ions are going to be distributed funny, and it may affect the membrane voltage of the muscles, and then they may resist contraction. And eventually you just can't contract your muscles like you could because of those ion imbalances. So sodium-potassium pumps don't function. Affects membrane voltage. Another thing that can affect or cause fatigue is a decrease in acetylcholine. Those somatic motor neurons have to release acetylcholine every time we want a muscle fiber to contract. Where does that acetylcholine come from? Cells have to make it. Those somatic motor neurons have to make that acetylcholine. What's it going to take to make it? ATP and enzymes. And if the pH of these tissues changes, it could affect ATP production. So it's kind of this big snowball effect. All of these kind of relate to one another. And then probably one of the biggest ones that is something that every athlete needs to work on is mental. The lack of the desire to continue. I just don't want to run anymore today. I'm done. I just can't do it. I know when I was running, I used to say, okay, I'm going to run for 25 minutes. And then I would, look at my watch and say, all right, it's 24 and a half. I'm going to push myself another minute and a half. I'm going to go to 26 or 27. That's part of that mental conditioning, is just kind of forcing yourself to do it a little bit at a time. So all these affect fatigue and lead to muscle weakness and the loss of the ability for muscle to contract. And training and conditioning helps to negate these, if you will, to a point. Now I want to talk briefly about what's called lactic acid threshold. One of the things that can happen as you condition and become a more fit individual is that your body's tolerance for lactic acid increases, meaning you don't produce as much, and your body has ways of actually dealing with the lactic acid before it builds up to high levels. So here's your graph. You might see this on the exam. So this is lactic acid concentration here. So over time, as you're exercising, the level of lactic acid is going to stay low. It's going to slightly creep up. But it'll get to a point where it suddenly starts to rise very dramatically and very rapidly. What has happened at that point is you've reached your lactate threshold, or lactic acid threshold, meaning that there's just too much beyond this point. Your body can't do much about it. This is when it has the biggest effect on fatigue now. And fatigue happens very, very rapidly at this point. You ever experience hitting the wall? You're out running or exercising, and you're feeling great, and all of a sudden it's just like, oh, I can't do this anymore. Okay? That's typically when you've reached your lactic acid threshold, your lactate threshold. You just can't do it anymore. Your body, your cells can't do it anymore. Conditioning and training actually extends this out. It actually makes it go beyond here, and you hit that threshold later. And there's a variety of reasons why we extend that threshold out. I'll try to explain that as we talk about different types of muscle fibers and training and what that does. So I said over here that we had to basically, in a way, borrow energy. We had to borrow energy to get to the point of being in a steady state. Well, after exercise, we have a recovery period that allows us in a way to pay that debt back. Now, the term oxygen debt really isn't used anymore with this banking analogy. There's actually a better term that describes what's happening. It's called excess post-exercise oxygen consumption. EPOC. E-P-O-C. Excess post-exercise oxygen consumption. And it means exactly what it says. It refers to the amount of oxygen your body is requiring and consuming after you're done exercising. In very, very heavy exercises, this can be upwards of 11 liters per minute. 11 liters of oxygen per minute that your body's consuming, or that you're bringing in and using, and obviously you're breathing carbon dioxide out as well. Now, this volume will vary with activity. So what does this oxygen do for us in recovery? Well, it does a lot of things. A lot of it related to ATP production. And, as I said, paying that debt back. So, ATP production aerobically. Even though our muscles are not needing a lot of ATP at this point, we do need to produce significant amounts of ATP to aid the recovery process. So the ATP produced in this process is used to replenish the creatine phosphate. Because remember, we used that creatine phosphate to make ATP at the beginning of before we went jogging. It replenishes the ADP. Basically, it's converting AMP to ADP, and then that ADP is used to make more ATP. It's important for restoring oxygen to the myoglobin and the blood and tissues. ATP also is important for the Cori cycle. I mentioned that the other day, and that looks like this. Whoops. Cori cycle, remember, is where pyruvic acid is converted to lactic acid. Lactic acid then goes to the liver where it's converted back to pyruvic acid. Eventually, that pyruvic acid is converted to glucose. That takes ATP. It takes energy to do that. So some of that ATP generated in this epoch is important for regenerating glucose. What process would that be? Going from lactic acid, pyruvic acid to glucose. It's one of those G's. That gluconeogenesis. We're generating glucose from a non-carbohydrate substance. And we can take fructose or maltose or galactose and we can convert that to a glucose molecule. That's just carbohydrate to carbohydrate. But taking something that's not a carbohydrate and making it into a carbohydrate, that's gluconeogenesis. That takes energy. That glucose then can go back into the muscle cells and back into other cells of the body and be used in glycolysis to make ATP that's used to replenish the phosphagen systems, replenish the ADP, make more ATP. And we also have repair processes occurring. Tissue damage has occurred during exercise. So it's going to take ATP to facilitate those processes as well. And then we also have increased metabolic rates. Cells are undergoing, and this is part of the repair process and ATP production, but they have a higher demand for oxygen because they're doing more things. And they need to make their own ATP as well to power these processes. Part of the reason that we have these high metabolic rates in our cells after exercise is because during exercise we're releasing catecholamines. Remember what catecholamines are? Epinephrine, norepinephrine, dopamine, mainly epinephrine, norepinephrine that come from the adrenal medulla. Okay? Those are maintaining these high metabolic rates. And over time, as those hormones are diffusing out of the blood and eventually breaking down, those metabolic rates will decrease. So all this oxygen that we're bringing in during this time period is important ultimately to generate ATP, which that ATP then does a variety of things, including repair and replacement and things of that nature.